In today's video, we're going to be covering the independent two-sample t-test in Python through 3 different examples. Our first example is going to be a manual calculation. Then I'm going to show you how SciPy can be used with 1 or 2 tails to make your life so much easier. But before we jump into the Python code, let's go over a little bit more information on exactly what is an independent two-sample t-test. Today, we're going to take a look at the independent two-sample t-test. This is also known as the unpaired t-test, a statistical method used to compare the means of two independent groups to determine if there's a significant difference between them. This test assumes that the data comes from a normal distribution and the two groups are independent of each other. If you want to compare the means across multiple groups, we'll be using ANOVA. I'm not covering that in this video, but I will be covering ANOVA later on in this playlist. Some examples, independent two-sample t-test, right? Imagine test scores between two different classes. Right? And another one would be the effect of shoes on marathon times. Imagine like you're using a Vaporfly, or if you're going to be using Pegasus. Those are both Nike shoes if you aren't running nerds. But regardless, right, they're going to have some sort of impact, but you're going to use the independent two-sample t-test to confirm that or not. Now, let's talk about pooled versus Welch's t-test. So if we have equal variances, we're going to use pooled. If not equal variances, we're going to use Welch's t-test. I'm going to be covering Welch's t-test in the next video. So the assumption in this video is they're going to be equal variances. I'll show you how we can test the equal variances. I actually covered that in another video in this playlist. If you're watching this for the first time, I do recommend checking out the other video, but we can continue moving forward. But there's different ways to calculate your t-statistic and your degrees of freedom. All right, so to see if you have equal variance or different variance, you want to use Levene's test, and essentially it confirms or rejects the equal variance. Null hypothesis is that all variances are equal. Alternative hypothesis, at least one's different. Typically, your significance level is 0.05. And this is the video I've already covered on the channel. So if you want to watch Levene's, awesome. This video will not focus on Levene's, so just want to call that out. All right, so back to our independent two-sample t-test, right? Here's our null hypothesis and alternative. Null hypothesis states that the means of the two groups are equal. Alternative that states that the significance, there's a difference between the two groups, right? When they're means. There's also one versus two-tailed. So a two-tailed is just looking at the difference. One-tailed may say one group is larger or is smaller. So you can use both. In my examples in the Python coding side of things, we'll have both as well. All right, so here's the steps on your independent two-sample t-test. One is to find null and alternative hypothesis, confidence level, and tail direction. Then you want to find the means. Then you want to perform Levene's test. Then you want to find the pooled variance, calculate t-statistic, find degrees of freedom, p-value, compare p-value to significant value, and make a conclusion. A lot of steps. All right, so let's say we want to compare the 10K times between two running clubs. Null hypothesis, there is no significant difference between the average 10K time of the two running clubs. Alternative, there's a significant difference between the average 10K times of two running clubs. This is a two-tailed test. Since we're just looking for the difference, we're not specifying any direction. Confidence level is 95%. All right, so first you want to find the mean of both clubs. Club A is 49.6. Club B is 56.5. Then you want to follow Levene's test. From Levene's test, we get a p-value of 0.11, and we fail to reject the null hypothesis of equal variance. We can assume that equal variance and proceed of pooled variance. All right, then we want to calculate our pooled variance. So variance of A, running club A, 3.6, running club B, 2.72. We run this formula, which is right over here. We get 3.14. Then we can calculate our t-statistic, right? Take the means. Then we have our pooled variance, 1 over n for each of those. We get negative 8.08. All right, find our degrees of freedom, right? 10 plus 10 minus 2 was 18. Then we find our p-value, which is almost 0. And since our p-value is less than alpha, we reject the null hypothesis and conclude that there's a significant difference in the average 10K times between club A and club B. All right, with this background out of the way, I think we're ready to start coding in Python. So make sure to grab your notebook and let's get going. All right, so let's get started. Import NumPy as NP from SciPy, import stats. And with these out of the way, we're ready to code. And I want to set up a random seed. So np.random.seed. And over here, we'll put in 42. Jackie Robinson's number. And we'll set our alpha value for the video. We'll say it's 0.05. All right, and great. So let's take a look at example 1, which is going to be a manual calc. So example 1. So we'll say there's no difference. There's no difference in K per 9 averages between the two teams. And we'll say there is a difference between the two teams. So we'll say team A over here, and these are numbers 9.2, 8.5, 8.9, 9.7, 9.1, 8.8, 9.4, 9, 8.6, and 9.3. And then we'll set up team B over here. And team B, 7.5, 7.9, 7.4, 8.1, 8.77, 7.8, 7.9, 7.6, 7.3, and 7.8. Feel free to use whatever numbers you want, but this is what I've prepped for the video. All right, so let's find the mean for both of these. So I'll say mean team A, K per 9 equals NP dot mean. Pass in this over here. And then we'll print out this mean over here. So just grab mean team A9 over there. And you can see the mean is 9.04. K per 9, by the way, if you're not a baseball fan, is strikeouts per 9 innings. All right. And let's grab mean team B. So just change this to B for both of these. And we'll print that out also. Print that. Super easy. 7.7. So, you know, about 1.3 difference between the two. Is that going to be significant enough? We'll see. All right. So first thing we're going to do is we're going to run our Levene test. So what we can do is Levene stat and Levene p-value equals stats Levene team A K9 and then team B K per 9. Have those over here, and we can print out our Levene p-value, and we want to have a value that's greater than 0.05. That's our alpha, and we get 0.272. So, right, we can assume that they have equal variances. Awesome. We can keep moving forward. And let's find the lengths of both of these teams. So NA equals length team A K per 9. Right. And we'll do NB equals length team B this time, although they are the same length. All right. Got both of those. I'll just print out one of these just to show you it's working properly. Great. Let's print this out over here. 10. Awesome. Let's keep moving forward. Let's find the variance for both these. So I'll say variance of A equals NP dot var. Then inside over here, team A K9. And then we'll set DDOF equals 1, right? Sample variance. And then do the same thing for B. Grab that over here. And then we'll print out both of these. So print variance at A 0.136. Print, they should be very similar. Print B 0.6. A little bit off, but not too far off. And then let's calculate our pooled variance. So we'll say pooled variance equals, and this is going to take a little bit of work, but we'll get through it. So we'll say NA minus 1, let's say times variance of A plus, and then we'll have over here NB minus 1 times variance of B. And let me just double check my parentheses really quick. So I have 2 here, 1 times var A, doesn't need to have that close there, plus nb minus 1 times var B. Cool. And then we're going to divide by na plus nb minus 2. Right. Great. Let's print this out. I actually didn't print this out in my example code, so hopefully this is correct. 0.009. All right, and now let's find our t-statistic. Let's say t-stat equals. And what we'll do is we'll take these means, which I call these means over here. And take A minus B. And then we'll divide this by np dot square root. Take our pooled variance times, and then over here 1 divided by na, and then we'll say plus 1 divided by nb. All right, now let's find degrees of freedom. df equals na plus nb minus 2, which we already did that in our calculation right over here. We could have just populated that. Now let's get our p-value. P-value equals stats.t.sf np.abs t-stat, our degrees of freedom, times that by 2, because it's a two-tailed test. And print, we should have a value essentially 0. This worked correctly. And yeah, awesome. So our p-value is close to 0, right? Which is less than alpha. So I'm going to copy and paste what I did in some other videos. P-value is less than alpha, reject the null hypothesis. And there's a significant difference between the two teams' k/9 averages. Otherwise, you fail to reject the null hypothesis. There's no significant difference between the two teams. Obviously, there is. We rejected the null hypothesis. Awesome. That was the manual example. This next example is going to be much easier. All right. So our second example, much easier, by the way. So example 2, we're going to look at a two-tailed test, and we're going to look at 10K times. So let's go ahead and do that. And we'll look at the two clubs. And this should look familiar because this is going to be our same example from earlier that we did on the slides. So I'm just going to copy over our times between both of these. I'm going to show you how much easier this is, right, with Python. So club A, we also have club B. Now what we want to do is find our Levene values. So we'll say, we'll grab what we actually did earlier, which is right over here. And this time we just pass in club A and club B. What I didn't do on that first one though is set a center. So I'll just set a center equals mean on this one over here. And awesome, we have that on this side of things. Just print out our p-value. Should be over 0.05. And we are 0.36. Awesome. And now we know we're not going to reject that null hypothesis. And now what we can do is get our other values. So we can say t-stat and p-value equals stats.t-test right over here. Then pass in both these, club A, club B. And then what we want to say is equal variance, so equal var equals true. Right? Remember, there's multiple ways to calculate this. So make sure we mention that the variance, it's not var, but VAR, is the same, right? Great. And let's print out our t-statistic. So print out, we should have negative 8.08, which is what we got in the slides. And our p-value should be close to 0. our t-stat, right? Negative 8.08, awesome. And then this should be close to 0. And it is. So we know that these two clubs, they have different averages on the 10K time, right? Club A versus Club B. Again, we went through all the math on the slides, so that's why I didn't really print out anything else over here. But right, that value is over there. We could write an if-else statement, right? If less than alpha, reject null hypothesis, blah, blah, blah. And yeah, cool. Let's take a look at example 3 now. Another running example. So example 3, we're going to look at the 400 meter race that I've never done. 400 meter example. And nice quarter mile, if you guys don't know what that converts to. And this time we're going to look at a one-tail example. So let's say we're taking a look at professional runners versus college athletes, and we want to see if the professional runners are faster than the college athletes, right? So what I'll do over here is we'll say professional runners equals np.random and normal. And this is why I set earlier the NP value for NumPy, the B42. That way you guys can replicate my results. But we'll say on the professional, we'll have the mean around 44 seconds, 1 second standard deviation, and then we'll have 30 different runners. And man, I'd be nowhere near a 44 second 400 meter. That's insane. And then we'll do the same over here for college runners. So just do college. And college runners are slower, right? So let's say that they are 48 seconds, 4 seconds slower. We'll keep the 1 standard deviation, and then we'll also do 30 runners. Great. And we can print out some of these over here if we really want to. We'll just show you what this looks like. Professional runners. This over here. My notebook is running a little slow today. I don't know why. And you can see some of our runners 44.49, 43.86, 44.64, 52, and 43.76. All right. So what we want to do first, we'll go back over here and grab our values for Levene, right? And then we'll pass in professional and college runners. First thing we want to do is we want to make sure that these have equal variance. So print out our Levene p-value, and should be over 0.05, and it's 0.644, which means they have equal variance, which is awesome. And again, we could do an if-else if we want to, right? If p-value Levene, which I named this Levene p-value, less than alpha, reject null hypothesis, different variance, right? Fail to reject null hypothesis, same variance. Just feel like you guys didn't need all these if-else statements all the time. But now what we can do is create our t-statistic, right? And get our p-value. And pretty easy, right? We'll say t-stat p-value. And we'll do over here equals stats t-test d, and we'll have in here college runners and our professionals. So just grab those college runners, professionals, and we'll say equal var equals true. So equal var is true. And we'll print out our t-stats, which is 17. And we'll also print out our p-value, which is close to 0, right? And what we need to do now is divide our p-value by 2, although it doesn't really matter at this point, right? It's so small, but regardless, we'll just take our p-value divided by 2 because that gives us the two-tailed value. I should have probably mentioned two-tailed p-value. So I apologize on that side of things. You could also just throw this in for here. So we'll say p-value final equals divided by 2. And we print this out. Again, we just print this out, this side of things, right? That is way less than our alpha value. So what we can say, print this out. Here, there's a significant difference. College athletes are slower than professional runners. Reject HO. And yeah, that's our independent 2-sample t-test. Just remember, when we use SciPy, it gives us 2-tail, so just divide that by 2 in this case. And overall, not too bad. We went through a manual process. It's a little bit of work. And then on the SciPy side of things, it's literally 1 line. Just make sure that if they are equal variance, you mention that over here. So equal variance equals true to get your correct values. And just remember p-value being less than alpha. Well, that's it for the independent 2-sample t-test video. Hope you learned something new. And if you did, make sure to subscribe to the channel. We're trying to reach 100,000 subscribers in 2025. We're going to upload at least 3 different data science focused videos every single week. Now, if you want to continue to learn more about statistics, I have a few videos linked down below in the description that I think you would find helpful, and a playlist right over here with all the videos.